Okay. First of all, my apologies for forgetting to announce it. I thought I announced it, and then I forgot that I didn't announce it. So let me go. Okay. Last time we have started with looking at different types of drawings. Okay. And what we have seen earlier was what type of drawings we have. For example, excavation plan, which you can use for calculating the excavation work required. We did a very small example, okay, where the plot area was very short and the difference in elevation was not so much. And then we looked at the beam framing plan. I discussed why we need to code the beams and the columns, so it will help us with the detailing of these items. And then you have the detailed drawings, which are the cross sections, okay, and the cross sections can be longitudinal or they can be cross, okay, and each of them basically, if it is a reinforced concrete member, then it will tell you about the reinforcement. Most important element of the details is the reinforcement, okay. When we are making these details drawings, on which point do we normally focus? For example, I asked you to give me a cross section of this column or a beam. Okay, so what will be your focus area when you are cutting the cross section? So this is the column, right? Okay. Which part of the column should I focus on in my details? Which cross section? I can cut the cross section at 1 meter, 2 meters, 3.5 meters. The column is going up, right? It will go from the ground till the roof. So I can have a cross section after every 1 millimeter, right? You can imagine how many cross sections I would have. Okay, I forget about the cross section. Okay, if I cut a longitudinal section, what am I most interested in? Which part of the column I am most interested in my cross section?
The start and end.
The start and end. Very good. Why?
Because we have the reinforcement connection.
Connections, yes. Most important element of the cross sections and the detailed drawings is the connections, okay, and obviously the reinforcement are part of it. But you will see in these drawings, wherever there is a connection, we go in more details. Okay. For the rest of the element, you will see. Is it here? Yes. You will see something like this. What does it mean? Everybody has taken 160, right? It shows what? Section. It shows a section. Anybody else? Yeah, this is a part. So this is continuing forward. Okay? Clear? This is not the symbol of a section. Okay? Symbol of a section is, it's not here. But you know, it's 2 arrows. Basically. Okay? So this is not the symbol of a section. I'm not cutting a section here. Okay? Symbol of a section is an arrow like this and then like this. Okay? It's a C with 2 arrows. So going back to the point that in your details, in your cross sections, the most important thing you have to focus is the connections. Okay. So and then we have done the calculations for the stirrups as well, and in these calculations we saw that if you miss a small part of the stirrup, it can have a huge impact on your cost. So when you are making these calculations, you need to be very, very accurate. Okay, and this is the column plan, which tells you the size of the column, the number of columns and type of columns. Again, you can see the coding. Okay, and then you can have a table where shows that C1 means how much reinforcement, C2 means how much reinforcement, and then you have the details and the drawings as well. For columns, you may focus on the connection of the column with the footing. Okay, then we have the slab drawing, and you can have 2 types of slabs. Okay, we have first one which is in situ, the second one is precast. Okay, in situ means you are making the slab on the side. Precast means slab is made somewhere else and they bring it and you install it on the site. Okay, Why is this important? Anybody remembers? Why we need to know which type of slab we have? We are calculating quantity, right? I will not make the slab, whether it is in situ or precast. So why it is important for me? It is the same slab, same room, right? Whether I make the slab in cast or in situ or precast, that should not matter to me. Yes. The method will change the cost. How? You are right. The method will change the cost.
Yeah. This I can make it on the side also.
So what are you calculating the cost for in this case?
Steel and concrete.
Sorry? Concrete, right? Steel and concrete. Okay, and about the second one?
Just the slab.
Slab. Okay, and slab can be per unit area. Okay, so your price mechanism will totally change. In this case, you may give me a cost per square meters. In this case, you will tell me per cubic meter of concrete. Okay, then we have the staircase. The important elements of the staircase are the landing beam, the landing slab, the landing beam, the base slab, and the landing slab again. And then we have the steps, and each step is made up of a riser and a tread. Okay, this is called a riser and a tread. Riser and tread do not have reinforcement, but the slabs and the beams, obviously, they have reinforcements. Okay, and then you can make these reinforced members with steel as well. And the benefit of using steel is that you have manuals in which you can see the total weight of the steel member. Okay, so calculations become easier, but the problem with the steel is that you cannot steel members. Yeah, steel bar, fine. We have lots of variety. Okay, but steel members like this, like you have to ask your contractor. So I cannot choose any size I want. Okay, and I told you there's a manual. So even if you look in the manual, you may not find a size of I-beam which has a thickness of 2 millimeters, maybe. I'm not sure. Okay, but the point is the sizes are fixed in the manual as well as in your industry. Okay. So you cannot say, okay, I will select any site and the contractor will make it for me. Maybe he will not make it for you. Okay. So there's less flexibility, but the work is easier. This is a table which you can use later on. Okay. And we did the calculation of how we can get the kilogram per meter of steel bar. We were using two things. What was that? How do I get kilogram per meter? What do I need? I need two items. Unit weight, okay, density, unit weight, and what? Cross-sectional area. Okay. So if you know the dia, you can calculate cross-sectional area, multiply by the unit weight, you get the kilogram per meter, and they are given in different units. This is something which I found. It's an online tool. You can use it to calculate different quantities, but still you need to know how to calculate the quantity. Okay, because the tool may ask you for length of the hook and you don't know what is the hook. Okay, or you may see the tool, okay, I can calculate the length of the stirrup, but what is the stirrup? I don't know. Okay, or the tool may give you two different items, one for precast and other one for in situ slab, but you don't know the difference between them. Okay, so you have tools, you have softwares. We have a software. If we have time and I can learn about it, then we will go through it. Okay, maybe a couple of classes. Like I know about the software, but I haven't used it. So if you have time, if I have time, then we may go through it. But so the point is, there are software, you upload the drawing and it can like do 60-70% of the work for you. Okay, there are tools like this, but again you cannot use these tools if you do not know the concepts behind them. Okay, clear? Everybody, clear? Couple of years ago, I was teaching report writing. You guys don't have it. There's a course, report writing, something. Okay. And now we have junior project, right? That time they had report writing in the previous syllabus. So I asked the students to make a CV. I told you guys to do something. Go to, you were with me, right? Junior project. No. Which one did you take last semester? And what was that? Introduction to whatever. Everybody forgets. So, the point is, at that time, in that course, I asked them to make a CV. Okay? And you know how did you guys make this? Huh? Okay? So that guy did the same. He opened that and he said, okay, make a CV. And the program made the CV for him or her, I don't remember. Okay, but the CV said he knows this software, he is a very good manager, and so on. Come on. We are still in your second year. Okay, so the point, going back to the point, if you don't know what you are supposed to get, you cannot use these tools. Okay, keep it in mind. If you don't know what you are supposed to get from these tools, you cannot use them. Okay. We did the excavation volume for this plan. Okay, and we assumed that we have a depth of 1 meter. Okay, and we calculated it for each footing separately. So it was slightly different from the example which we did earlier. How much volume did we get? Tell me.
7, 8, 5, 10.
This is what?
Kilogram per meter.
Huh?
Kilogram per meter cube.
The quantity of excavation. One second. What you are telling me is unit weight of steel. That was different. Okay, so we calculated that, and we calculated the concrete required for this beam. Okay, and how much was that? How much?
7, 8, 5, 9. What I do this one?
You are stuck. Yes. You have to move forward with your life and your slides and your notes. We did the same thing in the last lecture as well, huh? With 400 meter depth. 400 meter. Sorry? 0.09. 0.09. 6 into
No, 0.9 meter cube.
0.9.
Yeah.
Everybody remembers.
6, 0.3, 0.5.
Okay. Now we'll do the other things, okay, to complete the quantity of the beam. And again, after this, we will look at how to report them. So there's a standard method of reporting them as well. Right now, we are just focusing on the calculations. Okay. Now, so you have the concrete. Now we will have the steel. Okay. We have two types of steel here. In the beam, I have two types of steel. What two types? Sorry? Down and up? No, two types you mean down and up?
Y12 and Y25.
Y12 and Y25. Okay. This is one way to put it. Which one is it?
1.5.
Okay. Any other? Okay. So he is saying we can divide it according to the size. Okay. One is 25. The other one is there's 20 as well, right? There's 20 as well. Okay, so there's 25, there's 20, and there's 12. Okay, now B means it's like an extra bar at the bottom. Okay, T means it's the tension bar which is at the top. So this is something which you will learn in design. 160 you may have seen it. Okay, but we are focusing on the quantities right now. Okay, what else? So I have this one, this one, this one. What else?
Stirrup.
Stirrups. Okay, so I was basically talking about these two. Okay, we have longitudinal bars. Okay, and we have the stirrups. I was talking about these two. Okay, why? Because then the length calculations are similar. For longitudinal bars, the length calculation is same. The stirrups length calculation is same. In that case, we have like two types. So that was that. This is what I was talking about. Stirrups we have done earlier, right? Stirrups we have done earlier. Okay, guide me. I have. How do I calculate the length of one stirrup? Tell me. You have the cross section in front of you. Okay. So what do I add? The stirrup. Tell me.
Parameter.
Huh?
Parameter plus.
Parameter how much? How much is the parameter?
1,600.
Huh?
1,600.
1,600. How? Like what did it do?
300 multiplied by 2 plus 500 multiplied by
300 multiplied by 2, 500 multiplied by 2. It's missing something.
2. Yeah,
cover.
yeah.
The cover. Okay. So 500 into 2 plus 300 into 2. If you go like this, 300, 300, 500, 500. But on each side, I need a cover. Okay. The stirrup cannot go up to the face of the beam. Okay. How much was the cover? 25. How many times? 4 times, right? Are we done? Is this the length of the stirrup?
No, that's the thing called.
What's the thing called?
I forget this name.
Yes, what's the thing called? You were there last time or not? What's the thing called?
Just
Yeah.
Box.
Huh? Hooks, yes. In the previous meeting we had with the students, there were some good students who were saying that you should let us repeat the course even if you got B, because we can get A. Right now you have to get how much? C minus or something, right? To repeat the course, you need C minus, right?
Yes.
Okay. So there were some students who were good. They said no, even at B let us repeat because we can get A. Okay. And the reason why we don't do this is because of this. Like he has the answer to everything. So what did you get in this course
D.
last time? Huh?
D.
D. Why? What happened? Dr. Hassan didn't like you.
What?
Dr. Hassan didn't like you.
Maybe.
Yeah. I like you, but you may still get D. Okay, the hooks. The hooks, I told you normally 9 times dia or 10 times dia. 9 or 10, the other end. Okay. So I will add it, obviously, the hooks. Okay. So 9 times dia. What is the dia?
95.
95. Where is it? It says number 8. Where is 25? No, those are. See, number 8 is stirrups. See, number 8 is stirrups. Okay, so 25. Anything else? Anything else? It's a hook. I'll show you the last drawing. It was more clear. Yes, am I missing something? Here. Yes, tell me. Tell me you were saying it. Huh?
Multiply it by 2.
Multiply by 2. This is what you were saying. Multiply by 2, right? That's the hook, it's a knot, okay? So you need both ends, right? You cannot make a knot with one side, right? You need both, okay? So that's why I multiply by 2. Okay, how much is this? How much is this? Yes, how much is it?
1,900.
Okay, this is in millimeters, right? Everything was in millimeters. This is one stirrup. This is one stirrup. How do I get the number of stirrups? Each one is at a spacing of?
150.
What is the spacing for each stirrup? Now see, it is now interesting. See now, what is happening? Yes? Two spacings. Okay. This is normally, again, whenever these things come up, I need to explain it to you. Stirrups near the supports are closer. Stirrups in the middle have more spacing. Stirrups near the support is what? It's a beam. So beam is on. What is the support of the beam? What are the supports of the beam? Columns, right? Okay. So near the columns, the stirrup spacing will be less. In the middle, the stirrup spacing will be more. Okay. And again, you can see the rule here. Actually, the total length is how much? 6,000, right? And what is the length for smaller spacing? 2,000, which is length by length upon what? What did they do? How much of the length? Total is 6. They took 2 for the closer spacing, right?
1,000.
No, for one side. 2,000. 2,000 is how much of the length? 1 by 4, 1 by 3, half, what? How much? 6 by 2 by 6 is how much?
1,000.
1/3, right? Okay, so this is another thumb rule you have to remember or keep it in your mind. Whenever we are providing something just for the supports, it is normally 1/3 of the length near the support. Okay, the total length was 6. Okay, for closer spacing, I took 1/3 of 6 on this side, 1/3 of 6 on this side. Okay, so 1/3 of 6 is 2 here, 2 here. Clear? Clear? Okay, I'm just telling you that these things are not like hard maths. That if I have to drive something and I have to do double differentiation or something like this. Okay, I told you. They are not applying in numerical methods here. Most of these things are thumb rules. Okay, even if they are calculations, they are not doing that much. Okay, so number of stirrups. Number will change according to the length. According to the spacing. But will the length change? Is there any change in length for the stirrups near the column or in the middle? No, right? It's the same beam, right? You cannot change the length. You don't have to change the length. Got it? Okay. So, how do I calculate, or what was I doing to calculate the number of stirrups? What did we do? We take the length,
We multiply by the gap.
divide by the gap, divide by the spacing.
Plus 1.
On each side, 150. Okay. This is only for one side. Multiply by 2. Okay. Not like this. Sorry.
Plus 1. Then
Plus 1. Plus 1. Okay. So length divided by spacing plus 1. This will give you number of stirrups. Then multiply by 2. Clear? For each side. Clear? Plus, now tell me for the middle. Huh? Yes. How much is the length now? 2000. Divide by 200, right? Yes. Middle is only one. So how many? Yes. Any question?
79.6.
Sorry, how much? 39.7. Okay. 39, right? It was 39 points. Yes.
Why do we divide it over 150?
Because the spacing near the columns is 150. Okay. Okay, it was 39 point something. I made it 40. Okay. Clear or not? If it was 39.1, if it was 39.1, will you take 39 or 40? 40. Why? That's from round up, okay, because this is quantity. Okay, if you make it 39, then you are 0.1 short. Okay, so because of that 0.1, you may not put the last stirrup. Okay, you have to keep this in mind. Okay, now each stirrup is this length, and I have 40 stirrups. Okay, so this multiplied with this, how much? So total length of stirrup, how much? 19550 multiplied by 40, how much? Huh? 787.
No. 7.
7830. Okay, this is now what millimeters? Clear? Okay. Okay, now we are left with the longitudinal bars. Okay, longitudinal bars. In this case, the good thing is they are all of the same length. Okay, but you can have extra bars at the top and the bottom and so on and so forth. You will learn about them later on. Okay, but longitudinal bars are very easy. Okay, they are going from here to here. Numbers are already given. Okay, so here to here, how much? Tell me. 6,000 plus. Okay, so plus 200 for columns on each side. Then what else? Should I add or subtract anything? Tell me. What should I subtract? I did it for the stirrup as well. Look at the stirrup. What did I subtract? The cover. Okay, so I need to subtract the cover. Cover same, right? Same. And for each side. So 2. Now look at the drawing and tell me what should I add?
The extra.
Which extra?
The y12.
Huh?
With the bottom and
Say again.
the extra bars.
Which extra bars? I'm talking about the length for the time being. The length. Yes, any question?
So what's the long what?
Long bars.
Bars?
Bars. Steel bar.
Bars.
Bar. type it on the slide. Computers were invented for people who have handwriting like me. So where's me? Okay. Anyways. So what extra should I add here? I'm missing something here. What am I missing?
Because we consider the overlapping for the
Which one?
reinforcement, the odds.
Which
The
overlap?
end.
The end, yes. Okay, so we need to add this thing. Okay, we need to add this thing. Okay, now this thing, the one which you see going straight down, it is normally 6 times of dia. 6 times of dia, the thing which is going down. Okay, and since these bars are very thick, the stirrups are thin bars. You see, number 8 dia. Number 8 dia is very small. Okay, this is number 25 and number 20. So these are thick bars. Okay, so when you bend them, this bend will also take some length. Okay, the bend will not be small. Getting my point? Okay, if I bend this wire is very small, right? So if I bend it, I don't need much length because it's very thin. Okay, but if I for example, if I bottle, how would I bend it? I can bend that one. Still has water come. No, keep it.
But then,
And you want to test how strong I am, right? Anyway, but you get the point, okay? If I try to bend this thing, the bend length will be something significant, right? I cannot ignore it. Okay, if something thin is bent, the bending length is not so much. Okay, but if I bend something thick, the bending length will be something which I should not ignore. So this bend length is considered as 2 times of dia. Okay, this bend is 2 times of dia, and then this thing which is straight is 6 times of dia. So total 8 times of dia. Okay, now here is a thing where you have to separate the dias. Okay, how many bars of each dia I have? I have 2 of 12 dia, 2 of 25 dia, and 2 of 20, right? Their lengths are almost same. Their lengths are almost same. Okay, so what do? We can make it, okay, I will just write it here. So for 12 number dia, it will be 8 into 12. Okay, on each side. See, I have it on each side, right? Okay, this is for 12 number. For 20, 8, 20 to 2. For 25, 8, 25, 2. Clear? Okay, so that dials are different, so it will be different. Clear? Okay, but the rest will remain the same. This part will remain the same. Okay, so you will do it 3 times, only the last thing will change. Okay, any questions? Clear? Okay, what's the answer here? Tell me. Each one of them. What did you say? For each one?
96,
Huh? Say again. 6542. 6542.
no, so 6.
It's not 6542.
You want to go to the
One by one. One by one is for the sake of others. If you want total, we can check the total.
last one is 400.
What is with you and for? I need this full.
6,342.
6,342. And next,
300. Yes.
somebody please tell him what we are doing. we will do this whole, this plus this, okay?
6,470.
He is very happy. Yeah, I can do it without calculator. Only half the calculator. Yes.
6,470.
6,470. And we are doing it because the diameter is different. Okay, if the diameter was same, I would have done all of them, added them together. 6550. Okay, any problem? Any problem? Okay. Just check something before we move on. Okay, so far so good. Okay. Any questions? Okay. Now I need to the steel. In what units do we buy steel? In length? Huh? Tons. Okay. But I have what? Length. So I need to convert it into weight, right? I need to convert it into weight. Okay. What happened to you? Yes. Okay, so for weight we can use this table, but we don't have number 8 dial, right? Okay, we have what? We have 12 and 20 and 25. Do we have them here?
We have 12.7, we have 25.4.
Which one? Where is it? No, we don't have it. Okay, what was the unit weight now? Tell me.
One doctor?
Yes. Unit weight of steel. The one which you were telling me earlier.
Tons? For what?
7, 8 something.
Oh, okay.
7859.
7.8.
And was what? Kilogram per cubic meter? 7859.8 kilogram per meter cube. Okay, so what we will do is we will calculate per meter for each of these bars from the using the area. Okay, so for number 8, how much? This multiplied by what was it? Pi r square. So r is number 8, then r is 4. Okay, and then it must be divided by millimeter. And then square, right? Pi r square, right? So how much do you get? And you can, why should I do another step? I can directly multiply the total length that I have. Okay? Area into length will become volume, right? And then I will have the weight directly. So this is again 78,000 is 78 millimeters, 78 meters, right? 78 meters. Okay? Huh? It will give us the weight directly, kilograms.
This is for the stirrups?
Stirrups, yes.
What's the 78 doctor?
The total length of the stirrup.
Okay, meters.
Yeah, in meters. This was in millimeters. Everything is in millimeters, right? So how much is it? The weight of the stirrups?
Can we do the same for the next, but we change the diameter?
Diameter will change, the length will change, that's why the unit weight remains the same.
Sir, 785 number 8, it's given.
Huh? Yeah, he gave.
And the 4,
Huh?
4 radius.
Because it was 8 diameter, so 4 it is. We are doing it for the stirrups. The stirrup is 8 millimeter dia. Okay or not? Stirrups. Do you have the drawing?
Yeah.
Stirrups. You see number 8?
Hash 8.
Yes. How much is the weight of the stirrups? Tell me. Say again. 13.8 kilograms. 30. All of you have taken surveying, right? All of you have taken surveying. Okay. So in surveying, what they do is they never say numbers like 30, 13. They point it out one by one, digit by digit. So if I have to take 13 point something, I'll say 3, 0, and something. Okay. So this is for the stirrups. Any question? I'll repeat the same thing for the other bars. Unit weight is still steel, same. Area depends upon dia, right? Okay. Now we do it one by one. I have 25 dia. I have, sorry, where is it? Yeah, 25. No, 12, 20, and 25. Okay, 3 dias. I have to do it 3 times. Okay. So this remains the same. If the dia is 12, then radius is 6. Multiply by the length in meters. Clear? Any questions? Okay. Okay. Now you can do it for the other two dias, right? This will be replaced by half of these values, right? 10 and then half of 25, 12.5. So how much is the weight for each case? Tell me, how much is the weight for this one?
16.
15? 15.97 kilograms. Okay, what about this one? What did you do last time?
27.
250.
Yes.
25.2.
25.27.
Yes.
Okay, clear. Anybody has any questions? Okay. Now we can, all of them are steel, all of them have weight. I can add them together. Okay, total weight of steel, tell me. Total weight of steel, how much?
$46.84.
46.84 kilograms. 46? No.
77.6.
Added 4 values, right? 4 values. 70 kilograms. Normally we take it in tons, right? The steel is taken in tons. Divide by 1000. Okay. So 0.078 tons. There are 2 different types of tons. And Don't ask me which one is this one, but US and UK always have this problem. Yeah, huh? Yeah, so 1 ton is TON ton, another one is TONNE ton. And there's 2 types of gallons as well. All of them together. All steels together. All steels together. Okay, so it's better that you keep it with you. Next time we will do another part of this exercise. Okay, and then I will ask you to do something by yourselves. Any questions? Any problems? Why not?